Hi everyone. Now we are going to find the expression for potential due to a dipole. What is a dipole? Dipole is the arrangement of equal and opposite charges in a small distance. So we are going to consider a dipole of length 2a. Dipole consists of two charges minus and plus, minus q and plus q. The distance between the charge is 2a and we are considering a point here P, and this distance is R1, R2 and R. If we are taking the center, it will be A and it will be A. We are splitting that length 2A into two segments, A and A. And this distance is R1, this distance is R and this distance is R2. This angle is theta. So the point P is at an angle theta with the axis of dipole. We are drawing a perpendicular from the R2, the line R2 to charge Q, and if we are taking this length will be, the total length is R2 and this length is R1. So this length will be approximately equal to R2 minus R1, because this total length is R2, this length is R1, and to find this length we can use the equation entire length R2 minus this small length R1, small length R1. So it will be R2 minus R1. There are two charges minus q and plus q. V1 potential because of q1, V2 equal to potential because of q2. So since there are two charges, there will be two potential. One is V1 and one is V2. What is equation for V? Electrostatic potential. It is 1 by 4 pi epsilon 0 q upon r. That is equation. So the equation for V1 will be 1 by 4 pi epsilon 0 q upon plus q. The distance is r1, q upon r1. Then equation for V2 will be 1 by 4 pi epsilon 0 minus q upon the distance is R2. These are the two equations for electrostatic potential because of the charge minus q and because of the charge plus q. And to find the net potential, it is a scalar quantity. No need to think about the direction, because scalar quantity is not having direction. It is a quantity which is having only magnitude. So we can use a normal addition method. So V is equal to V1 plus V2. It will be V is equal to 1 by 4 pi epsilon 0 q upon R1 plus 1 by 4 pi epsilon 0 minus q upon R2. Q and 4 pi epsilon 0 is common factor, so it will be q upon 4 pi epsilon 0 1 by R1 minus this minus we are giving here 1 by R2. Now V is equal to q by 4 pi epsilon 0. It is in the form of 1 by A minus 1 by B. It will be B minus A into B. So R2 will go to numerator. This R1 will go to numerator and denominator will be the product of R1 and R2. R2 minus R1 by R1 R2. Now in this figure, this R2 minus R1 is this distance, and from we are considering this triangle. There is a triangle which include the angle theta . The equation is V is equal to q by 4 pi epsilon 0 R2 minus R1 by R1 R2. R1 and R2, they are approximately equal because the dipole is very small. So we can say that R1 and R2 is approximately equal to R. So we can write R1 R2 is equal to R square. These are equal because the dipole length is very small. This length is also very small. So we can approximate that. It is approximation. We can assume that these two lengths are approximately equal. So R1 R2 will be approximately equal to R square. And this angle is theta. If we are taking cos theta is adjacent side by hypotenuse, and if we are using the equation of cos theta adjacent side by hypotenuse, we can say that this side will be a cos theta, means this is adjacent side will be is equal to hypotenuse into cos theta, so it will be a cos theta. If this is a cos theta, this length is approximately half of this length, so if this is a cos theta, it will be 2a cos theta. So we can write R2 minus R1 is 2a cos theta. So R1 R2 is R square. Equation is going to change here. V is equal to Q by 4 pi epsilon 0. Instead of R2 minus R1, we can use 2a cos theta upon R square. This Q2a is known as dipole moment P. So it will be V equal to P cos theta upon 4 pi epsilon 0 R square. It is the equation for electrostatic potential at a point P because of this dipole. V equal to P cos theta upon 4 pi epsilon 0 R square. Now, if the angle is 0, means if the angle is 0, it is the point at axial point. It is at axial point. The equation will be cos 0 is 1, so it will be P by 4 pi epsilon 0 R square. If theta equal to 90 degree, it is at equatorial point, so V is equal to 0. If theta is equal to 180 degree, it is also axial point but it is in opposite direction. V is equal to minus P upon 4 pi epsilon 0 R square. Theta equal to 0 means the point will be here. Theta equal to 90 means the point will be here. Theta equal to 180 means the point will be here. So these two points are axial points. This point is point, equatorial point.